let's try this again. I think I have the microphone on. And let's go through week 4. And let's talk about the agenda and then systems of linear equations and then what your assignment is. Apparently, I can't type. So I had this issue. This shouldn't be a 0. It should be 420 to 427. It is week 4. Here's our plan for the next 4 weeks. I did ask you guys some questions. One of the things that came up was reviewing linear systems. So I'm going to review linear systems this week. We're not talking about quadratics. We're actually going to be talking about quadrilaterals. So we're going to talk about laterals. We're going to talk about quadrilaterals and systems of equations. There might be some quadratics in there, but that's what we're going to talk about. And then the third week will be 3D volume and surface area, so 3-dimensional figures. And then we're going to do a semester 2 wrap up as I think it'll be about our last week. And then I can tell you now with regards to grades, a lot of the stuff has been going into the formative assessment category. However, I can tell you now, this semester 2 wrap up will be kind of like a final exam. This will allow you to bring your grade up by probably about 5%, provided that you've done it and you've been on top of the distance learning and those kinds of things. This is going to be the best way for you to bring your grade up unless you need to redo Cougar Path 3.1 or Cougar Path 2.4. I've posted information about it. You guys need to take advantage and get this stuff done. If you don't, then, or you're happy with where your grade is, just keep, learning, just keep processing, just keep doing more of the math that I'm asking you guys to do. But grades are probably not going to jump from like an 81 to a 90. But, if you had an 88 to a 90, that's a legitimate jump of grades. So if you have other questions about grades, message me, text me, or remind me, or email me. So linear systems. We need to make sure we know what we're solving for. We need to make sure we review graphing, substitution, and elimination. And we're going to talk about the assignment. So let me choose another color. All right. So what is a system of equations? My guess is you've seen a picture like this. So, Phones R Us charges $64.59 monthly fee for unlimited talks and text and charges an additional $2.25 for each gigabyte of data. In an effort to bring in new customers, Cheap Phones runs a promotion charging only $29.49 a month for unlimited talk and text, but they charge $3.55 for each gigabyte of data used. So the graphs below show a comparison between the two data plans. So obviously these are linear functions because they grow based on the gigabytes of data, and that's your monthly phone bill. So line A. Line A appears to start at a lower value of monthly phone bill, but it grows a little bit faster than line B, which starts at a slightly higher value and grows at a slower rate. So line B, you're correct if you guessed that line B was cheap. Phones are us. And line A is cheap phones. So the y-intercept helps us identify that. The other thing that helps us identify that is the rate of change. So 355 is the rate of change for cheap phones. 225 is the rate of change for Phones R Us. Now, what are we looking for? When we solve a system of equations, we're looking for where the two equations are equal to each other. So we're looking for the point of intersection. We're looking for where We're looking for where x and y are the same for both equations. So at that number of gigabytes of data, the phone bill is identical. Okay, so how can we solve them? Well, there's 3 methods that you learned about in Algebra 1. You learned about graphing, substitution, and elimination. So graphing, let's just review. I'm going to go ahead and we're going to review each one. So I'm going to graph this one in this color. What's my slope? Correct. Slope is 4/3. What's my y-intercept? Yep, 1. Remember, you can always press pause at the beginning of the problem, do the problem, and then go back and watch the video to check your answers. So if I were to graph this, I'm going to press my value of my y-intercept. I'm going to count up my rise and my run. So I'm going to go up 1, 2, 3, 4, and right 1, 2, 3. The same that means, the opposite that means the same is to go down 4 and left 3. And when we do that, if I can draw a semi-straight line, there is the line for 4/3 x plus 1. Second equation. Y-intercept, or actually slope first, is -1/3. Y-intercept is -4. So I'm going to start at -4. I'm going to go down 1 and right 3, or up 1 and left 3, and we can very clearly start to see what the point of intersection is. So what we're doing is we're looking for this point here, the point where the two equations are the same, and that point of intersection is the point -3, -3. Now, one of the things that you guys have at your disposal is you have the use of Desmos. You also have the use of graphing calculators. Remember, we can graph them on our graphing device. So y, not x, y equals 4/3 x plus 1 is the first equation. Second equation is y equals -1/3 x, I think it was -4, yes. And there we can very clearly touch that point. We can see that our point of intersection is -3, -3, which is what we actually created. So that's graphing. All right, substitution. Substitution is when we have got one of the variables isolated. So if we look at this one, that variable y is isolated in both equations. So y is the same as y, right? Now, if y is the same as y, then that means 2x minus 1 has to be the same as -7x minus 1, which means I can rewrite my equation as 2x minus 1 equals -7x minus 1, because we know y is equal to y. Y is equal to 2x minus 1, so that's the same. And y is equal to -7x minus 1. Now we're just going to algebraize it by adding 1 to both sides. So 2x equals -7x plus 0. So I'm going to add 7x. 9x equals 0. Divide by 9. X is equal to 0. Now, once we know what x is, then we substitute that back in to one of the two equations. So y is equal to 2 times 0 minus 1, or 0 minus 1, or -1. Therefore, 3 dots means therefore, our point of intersection is the point 0, -1. So that's our first substitution example. All right. What could you do on this one? Press pause if you think you want to. Give it a try. And then go ahead and watch the video again. All right. This time, I know y is equal to -4x plus 23. So those two things are the same, right? All three things are the same that I highlighted the same color, which means I can keep my equation -3x plus 2, but instead of y, I'm going to replace that with what I highlighted, -4x plus 23. And the whole thing is still equal to -20. Now I'm just going to do my algebra and I'm going to distribute. So negative 3x minus 8x plus 46 equals negative 20. Add these together and get negative 11x plus 46 equals negative 20. We're going to subtract 46. Negative 11x is equal to negative 66. Divide by negative 11. X is equal to positive 6. Once I know x, I'm going to take that value and substitute it back into the original function. Y is equal to 4, negative 4 times 6 plus 23. Negative 24 plus 23 is equal to negative 1. Therefore, my point of intersection is the point 6, negative 1. So that's the second substitution one. So substitution can be done when they're both equal to y equals. Substitution can be done when one of them is y equals or x equals. Substitution can also be done when we can isolate one of our variables. So I'm going to take this equation here and I'm going to isolate negative 3x plus y equals 16. I'm going to get the y by itself by adding 3x to both sides. So that means y is equal to 3x plus 16. Now I can take that 3x plus 16 and substitute it into the first equation for y. So it gives me 6x plus 6 times 3x plus 16 equals 0. Again, I filled in my y with 3x plus 16. Distribute. 6x plus 18x plus 60 plus 36 plus 96 equals 0. 6x plus 18x is 24x. We're also going to subtract 96 from both sides. Equals negative 96. Divide by 24. Sorry, I'm yawning. It's the afternoon. I've already run and was a little annoyed that the video didn't record the first time I did this. So we're doing these problems again. Negative 96 divided by 24. I need a calculator. I think the answer is 4 though. Let's see. 96 divided by 24 is 4. But not positive 4, it is? You're right, negative 4. Now I know x. I'm going to substitute back in. Substitute back in here and solve for y. So y is equal to 3 times negative 4 plus 16. Negative 12 plus 16 or positive 4. Therefore, the point of intersection is negative 4, comma 4. Okay? So those are our 3 substitution problems. Now we're going to talk about our 3 elimination problems. Elimination means that we're trying to get rid of one of the variables very easily by adding the 2 equations top to bottom together. So take a look at this one. If I look very carefully, if I were to vertically, in elementary school where you learn 12 plus 36 and you do 2 plus 6 is 8 and 3 plus 1 is 48. You guys remember doing that? Good. So I'm going to erase that because that's not really needed, but we're going to do that vertical. So we're going to add these 2 equations together vertically. What is negative 2x and negative 5x? You're right, it's negative 7x. But what happens when we add negative 2y and positive 2y? You're right, they cancel out. They are, yes, eliminated. Equals altogether negative 14 when we combine them. Once we've eliminated a variable, we can solve for the second variable. X is equal to positive 2. Now we know that. Go back up. Negative 2 times positive 2 minus 2y equals negative 6. We end up with this. We have negative 4 minus 2y equals negative 6. We're going to add 4. Negative 2y equals negative 2. divided by negative 2, y is equal to 1. Therefore, your point of intersection is the point 2, comma, 1. So the first elimination type that we do is when our equations are actually set up that we can just add vertically and one of the variables will cancel out. It will subtract to 0 or add to 0. Second is, what happens if that doesn't work? But if I look at that first equation or the second equation, couldn't I make this negative 6x very easily? You're right. All I actually need to do is multiply that whole second equation by the number 2. So my first equation doesn't change. 6x plus 6y equals negative 6. However, my second equation, when I distribute the 2, gives me negative 6x, negative 4y, positive 2. Now I'm just going to combine like terms vertically. The 6x's cancel. 6y minus 4y is 2y. Negative 6 plus 2 is negative 4. So we're going to divide by 2. Y is equal to negative 2. Now I'm going to substitute that back in. So 6x plus 6 times negative 2 equals negative 6. 6x minus 12 equals negative 6. Add 12. 6x equals 6. Divide by 6. X is equal to 1. Therefore, your point of intersection is 1, comma, negative 2. Now, this one was easy because the y's automatically canceled. This one wasn't bad because we multiplied one equation by a number so that the x's would cancel. You could have also canceled the y's. If you had wanted to, you could have multiplied this by 3, and then the y's would have canceled. But either way, you can just multiply and it'll cause one of them to cancel, and then life will be pretty simple. All right, let's go on to number 13. Last example. 10 and negative 3. Anything? Ooh, they're not friendly. How about negative 4 and 6? Yeah, not so friendly either. But 4 and 6 both go into 12, don't they? You're right. So if I multiply the top equation by 3 and the bottom equation by 2, I think cool things will happen. So I'm going to distribute. I'm going to get negative 9x, negative 12y, and negative 51. I got to check my calculator. 3 times 17. Plus y again, because apparently I started yawning and now I can't stop. All right. 3 times 17 is negative 51. So that's the top equation. The bottom equation, I'm going to get 20x, 12y, and 40. Well, that's kind of cool because what then happens? Let's use blue. 12y's cancel. 20 minus 9 is 11x. Negative 51 plus 40 is negative 11. Divide by 11. X is equal to negative 1. So once I have x, I'm going to substitute back into one of the original equations. I'm going to go positive. So I'm going to do 10 times negative 1 plus 6y equals 20, as opposed to the one with negatives. But it doesn't really matter. You're going to get the same y value. So negative 10 plus 6y equals 20. Add 10. 6y equals 30. Divide by 6. Y is equal to 5. I feel like it's 4B and I'm really tired when it's a B day and I'm tired. But it's not a B day. I don't even know if it's an A or a B day. I don't think they exist anymore. But it is a day of the week and the video didn't record the microphone, so I'm doing this again. So what's my point of intersection? Hopefully you already wrote it down while I was babbling. Negative 1, comma 5. This is why I miss students. I feel like I'm weird because I'm talking to myself and I'm asking questions and nobody's answering, and it's just strange. So, checking your work. How could you guys check your work? Anybody have an idea? No. Well, I'm going to actually, I already took a screenshot of this the other day because I was doing this on my video. I'm going to check my work by using Desmos, and I would highly suggest you guys use Desmos as well to check your work. So I'm going to actually take the one that we just did, the negative 3x, not negative 3y, negative 3x minus 4y equals negative 17, and the second equation of 10x plus 6y equals 20. And I'm going to check my point of intersection and see that they intersect at negative 1 comma 5. And if we go back to our work, we see that they intersect at negative 1 comma 5. So let's check our work for number 11, this point of intersection one. And that's the cool thing with these, is that you can check your work by entering them into Desmos. If you use the graphing calculator, you have to solve them for y first because it's y equals. In Desmos, you don't need to solve the equations for y. You can just write them as they are. However, the challenge is that you can't use Desmos on the SAT. You have to use your graphing calculator. So it's not going to hurt for you to know how to check your work. And I would highly suggest checking your work on the problems that I'm going to actually assign. So, again, remember, log into office hours. My office hours, official math office hours are Thursdays. So I'm going to go from 1 to 3 on Thursdays. That's the official math office hours. However, if you don't need office hours on Tuesday or Wednesday for your other classes, please feel free to log in Tuesday morning, Wednesday morning, or Friday morning. And then afternoon office hours are normally Wednesday, Thursday, and Friday. Again, let me know what kind of help I can give you. Again, overall grades will probably, if you're doing all of the work that I'm asking you, grades will probably go up about 5%. Okay? It's not enough to take a, 72 and get a B. But it is enough to take a 77 and get it to a B. Okay? So be thinking about that stuff. The week 4 assignment, do the work on separate paper. It's no need to print it out, and then you're just going to submit the work in the Google form. Remember, in the Google form, if you open the Google form in Schoology, you have to open it in a Safari tab or a browser tab because it will not upload the Google pictures in the Google form in Schoology app. You have to open the form in a Google. You have to open the Google form in a browser. Hopefully this finds you guys well. I miss you because teaching to my iPad is weird. I miss students a lot. So I hope you guys are well. Take care, and I'll post this up as soon as